time to move on to the next protocol. I'm actually going to skip SMB altogether. Even though you can use SMB on Linux, that's generally something you see more often when you go into the Windows world, and you're unlikely to see it in the NCAA Cyber Games competition. However, I'm going to skip down over to HTTP. So HTTP stands for Hypertext Transfer Protocol. Whenever you're browsing the web, that website code actually gets sent to you via HTTP. So web developers, or the people who design those websites, can use a variety of different frameworks and a variety of different languages to actually create the website. From there, that website, no matter what language it was created in, gets converted to a combination of HTML, CSS, and JavaScript. These three languages are languages that can be understood by your web browser. HTML defines the contents of the web page, CSS further enhances how the web page looks, and JavaScript is responsible for making elements on the web page interactive. Once that HTML, CSS, and JavaScript is generated, it gets sent over to your web browser using the HTTP protocol. I'm not going to cover all of the vulnerabilities that are associated with web because web pen testing and web vulnerabilities is kind of its own category, and I could do an entire course of videos just on that. However, if you wanted to look into that more on your own time, I left a couple of resources you can check out here. So I mentioned OWASP has a great list of vulnerabilities and a list of attacks. They also have the web security checklist. So if you're looking to develop a really secure web application, going through their security checklist is fantastic. For a competition, may not make as much sense because you have a limited amount of time to actually secure your web application. The other thing that I want to mention is if you want to learn more about web attacks, I highly recommend Portswigger's Web Security Academy. You'll sometimes hear this called Portswigger Academy. This is free. You don't need to pay. All you need to do is sign up for an account, and you have both learning materials, which are written explanations of all different kinds of attacks and how they're carried out and how to secure against them. And then in addition to that, you have hands-on labs that you can practice all those attacks and you can practice securing against those attacks. And they go from easy level to expert level in some cases. So these are a couple resources I recommend checking out if you want to dig more into those web attacks. But honestly, there's so many web attacks that as a defender in a cyber defense competition like the NCAA Cyber Games, I would recommend just really closely monitoring your network traffic, really closely monitoring that log file. In this case, it's going to be the access.log. I'll show you how to do that in a second. And catching attackers as they get in, kicking them out, and then fixing the vulnerability. Before we actually get into that, I am going to talk about a couple really common ways in that I've seen used during cyber defense competitions. The first really common way in is with a default password on a login page. So a lot of the times you'll be given a website that has a lot of different files, so there's a lot to look at, and you may miss that there's a login page somewhere in there. And if the attackers in advance knew the username and password for that login page and you didn't change that, then that's a potential way that they could get in. Another thing you'll see a lot of is backdooring, especially when we're talking about web applications that run PHP. That I'm not going to talk about in this video because we're going to get more into that when we talk about persistence mechanisms. But for now, let me at least show you what an attacker using a default username and password would look like. Maybe I'll also showcase a password attack similarly to like we saw with SSH. You can also brute force or password spray or credential stuff those username and password combos in a web application. And I'm going to show you how we as defenders can catch attackers doing that. Back on my attacking machine, my target actually has a web service running on port 80. So if I'll do a quick nmap scan to get more information about it, if I say nmap-port 80, this should all look familiar to you, -sv, get the version, run the default scripts, 10.0.0.11 is our target. And it did take a little bit of time to run, but after we got our results back, we can see that port 80 is open, the assumed service is HTTP, and the actual service version that it's running, Apache HTTPD 2.4.59. I'm again going to skip looking up that version and seeing if it's outdated and if there's a publicly known exploit. I already know, let's say, that it's the up-to-date version of Apache. So I can go and I can check out that web application on port 80. So I'm going to open my web browser, which in Kali by default is Firefox. You can open it by clicking up here in the upper left corner. And to access that web page, I'm going to go to 10.0.0.11. By default, it's going to reach out on port 80. However, if we wanted to reach out on a different port, I'd put colon, and then I'd put that port. I can also explicitly specify 80 there. Visit that page, and you see we just get the Apache 2 Debian default page. As an attacker, there's not really much I can do with this default page, but there may be some pages on that web application that are actually hidden. So how does an attacker go about finding those hidden web pages? Well, in a web browser, what you can actually do is you can say / and then you can try to look for other web pages. So I can try to look for, I don't know, some bogus web page that definitely doesn't exist. And I'm going to get an error back that it says the requested URL was not found. However, if I put in a page that does exist, and knowing this in advance, I'm just going to put in one that does exist. So login.php, for example, exists. And now if I try to reach that page, you'll see that it brought me to an actual web page. Using this information, we can actually go ahead and we can try a bunch of the most common paths that are likely to be on the target. So for example, we could try login.php, we could try info.php, we could try those sorts of things, robots.txt. To make that easier, there are tools built into Kali Linux, such as dirb or dirbuster, that can be used to automate this process. And basically what we do is we take a word list of common file names that you might find, and we would add them to the end of our URL, which in this case is http 10.0.0.11, and we run that tool using that word list. I'm not going to show how to do that, and the reason for that is, well, as defenders, we already know what pages are present on our web server. We can actually go to the web server's files. In this case, I'm using Apache, so by default, the directory root or the actual location of those web files is in var www html, and listing out the files there, we can see index.html, login.php, and logout.php. As a red teamer for a cyber defense competition, again, a lot of the times the red team is given access to your environment in advance, or at least they know what it looks like. So they're probably going to know what your what kinds of files you have on there, so that they don't actually have to run that directory brute forcing or dirb or dirbuster. They don't have to go through that process of checking whether files are or aren't present. They're probably already going to know what's on there. Point is, going back to this, we have this nice login page. So let's take a closer look at how this login page actually works. So if I were to enter some random bogus username and some random bogus password, and I click login, I'm going to say don't save because I don't want to actually save those credentials. You'll notice that it tells me that I've entered the wrong username. This is an example of a bad error message because it gives me an idea as an attacker that I actually have an invalid username and not necessarily the password, you know what I mean? So I can focus on those usernames, find a valid username first, and then look for passwords. A much better error message would say something like, you have entered the wrong username or password, in which case I, as an attacker, would have no idea if I have to try other usernames or if I have to try other passwords. But I can try some usernames that I'm assuming will be on here. So admin, for example. Looks like I didn't really get anything back for that. Let's try that again. Again, it says I've entered the wrong username, but we could try something like user. And in this case, it tells me I've entered the wrong password. So that gives me an indication as an attacker that I've probably entered the right username and that user exists. So I can try root also. And that also tells me that I've entered the wrong password. So now I have a good idea that user and root are valid usernames. Now I could go ahead and I could try maybe some default password. So I know that the default password that I've been using before was ABC123. So I can again try that ABC123. And if I click login, it now says that we've entered the correct username and password. So in a more realistic scenario, you would actually log in and gain access to some sort of management page. And from there, maybe that management page allows an attacker to upload some kind of backdoor that then they can use to get in. Or maybe that management page somehow directly allows the attacker to run commands on the machine. It really can depend. The point is they have to go through this login portal. The attacker could also choose to, if they wanted to, they could try a list of usernames, and they could use a tool like, for example, FFUF or WFuzz to automatically enter that username in there in the request that gets sent over. And then from there, they can filter for different success or error messages and determine when they found a correct username. Make it all automated. They can try really large word lists. Same thing that we basically did with SSH, so I'm not really going too in-depth on that. From the defender's perspective, what does this look like? Well, because this was all done over HTTP, which is unencrypted, we can actually see all of the requests that the attacker made. So looking at this one right here, for example, I can right-click, follow HTTP stream, and we'll see exactly what the attacker asked for, which in this case, it's just looking for an icon. That's something Firefox does by default. And then, of course, our web server returned that it couldn't find that icon. But we can also see, hopefully if I go down here, we'll see some evidence of those logins. So if I right-click on this one, for example, and say follow HTTP stream, you can see the full login request here. So this is just a request for the page itself. This doesn't have any of the actual login data here. But you can see we requested that login.php page, and then the server responded and gave us the code for that login page. And I'm not going to pretend that I wrote the login page. I didn't. I just grabbed one from Tutorials Point. So not my code here. But the next thing that we did as an attacker is we tried to log in. So if we look at this request here, they say follow HTTP stream. You can see that when we were actually trying to log in, instead of using a GET request, we used a POST request. So HTTP actually has different keywords or different requests that you can make. GET is usually for retrieving the contents of a web page, and POST is usually for uploading some content to the page. So in this case, the content that we're uploading is the username and password information. And if you look down here in the actual data, we can see the username and password that the attacker tried. So this was the first one that we tried, so you can see the username is bogus, and the password is also bogus. And we can see the response that we got, and the response contained, you have entered the wrong username. Okay. So as you might have guessed, we can also filter this traffic to maybe look for evidence of something malicious. The first thing we can look for is we knew the attacker was getting in through or the attacker might be getting in through some sort of login. And we noticed that the actual request that's being used to upload information to that login form is a POST request as opposed to a GET request. So we can actually, over here, we can filter for only packets that contain a post request. So I can say http.request.method equals, and then enclosed in quotes, so it's a string, post. Sorry, I lied, not enclosed in quotes, just the word post. So if I run that, we see all of the actual post requests that were performed, in this case by the attacker. So if I go through them, I can actually see each of the individual usernames and passwords that the attacker tried before they gained one that actually worked. It is a little bit annoying to go through because now I have to retype it again. There we go. Now I can look at the next one, right click, follow HTTP stream. Again, you can see there we tried admin and we tried an empty password. And so everything that the attacker did, as long as it was HTTP and it wasn't encrypted, you can actually see that in Wireshark. Again, this is a lot of traffic to look through, and even though we narrowed it down by looking specifically for a post request, maybe there's something else that an attacker is doing, a different kind of web attack that doesn't involve logging in to some management page. Maybe instead they're taking advantage of a backdoor, in which case it would a lot of the times use a GET request instead. So one of the easier ways, I think, of actually monitoring and looking for evidence of malicious actions when it comes to HTTP is taking a look at the log files. So if I go back to the actual machine that's being attacked right here, by default, if you're using Apache, the log files are going to be located in var log Apache 2. So if I try to go there, var log Apache 2, you'll notice I get a permission denied. That's because normal users don't have permission to even read that directory. So I'm actually going to switch completely to using the root user temporarily, just so that we can read those logs. And I'll do that with sudo su. And su just tells it to switch user, and since I didn't specify an actual user, by default it switches me to root. And of course I ran that with sudo so that I actually have the permissions to switch to root. Now that I've switched to root, I should be able to change directory into var log Apache 2. And if I list out the contents of that directory, there are two important log files. There's access.log and error.log. So access.log contains every request that was sent to your server. Error.log contains any errors. So maybe the attacker sent a request that was somehow malformed and it caused an error. We could see that in the error log. I'm actually curious if I print out the error log, we'll see if I see anything. We do actually have a couple errors here. We have this interesting invalid method. Maybe that's the result of some Nmap scan that we did earlier. I'm not entirely sure. Point is, the important one here is I'm going to take a look at access.log. And in access.log, it's really clear to see every request that was made. So we can very directly see this post request that was made to login.php. The thing you won't see here is you won't actually see the data that was sent back and forth. If you wanted to see that, you'd have to kind of take the time from here and you'd have to go back and actually look at those traffic logs that we were looking at earlier. But at least you can see the requests that are made. A lot of the times, and this will make more sense when we actually talk about persistence mechanisms, I think I'll also be demonstrating it later in this video as well, but when the attacker uses a PHP backdoor to get in, a lot of the times you'll be able to see it directly here in the logs. Again, going back to Wireshark really quickly, one other point that I want to make, I already mentioned this earlier when we were talking about, when I showed you that FTP exploit. A lot of the times when an attacker gets in, let's say through HTTP, they're going to run something like who am I or ls. So another great thing to search for would be edit, find packet, and then in the packet bytes, you can search for something like who am I, or ls. And then if an attacker was actually able to leverage some sort of vulnerability and fully gain initial access through HTTP, it's very likely that you'll be able to find that in the traffic as well. How do we actually fix the vulnerability, or in other words, how do we change that username and password combination that the attacker used to log into that login page? Again, this can really depend on how the website is set up. In my example here, those credentials are actually hard-coded in the login.php file. So if I print out, or actually I'm going to use nano to edit login.php. Of course, I entered the password wrong. Try that again. And you actually can see a list of users that I have here, and that contains usernames and passwords. If we actually look at the code for validating that login, it checks whether the username exists in this user list, right? And the next thing it does is it checks if the corresponding username matches the corresponding password in that list. So going back to this list, if I wanted to change the password for user, I can just change that here, and I can make it something really secure. So I'm just entering some random characters here, and there's a secure password. I can also change the password for root over here, and maybe make it some secure password as well. A lot of the times, a web application will actually grab that data from a database. So you'll see something like MySQL and then connects to a database, and then you'll see some SQL or queries actually in the code there. And if that's the case, you're going to have to go into that you're going to have to actually connect to that SQL database, and you're going to have to change the username and password, or just the password, within the database itself. That's a little more complicated. It also depends what variant of SQL you're using, whether it's MySQL or Postgres or MS SQL. So I'm not really going to get into that too much, but just know that another place that a login form could grab that username and password from is from a database, and you might have to actually go in and change that username and password in the database itself.